Hello and welcome to the Upswing Physics. In this session, we will discuss a problem which was asked in last week Junior CO Super China Test Series. This was conducted on 7th August. Let's have the formal wording of the question, then we will discuss the conceptual part. A boy run on a circular path of radius capital R, that is 28 meter, with a constant speed u. Another boy start from the center of the path to catch the first boy. The second boy always remains on the radius connecting the center of the circle and the first boy and maintain magnitude of his velocity a constant v. If the time to chase is 10 plus x, then the value of x is. Here the value of pi is given as 22/7. Okay. So this question was originally picked from Pathfinder, little bit modified. The original question is like this. After the discussion, you can solve this question also. This is given in a Pathfinder book. So let's understand the conceptual part first, then we will have this part, okay? First, let's try to understand what exactly happening. Then we will think about what we need to use, right? The first line is a boy is running on a circular path of radius with a constant speed. Let's draw a circle here. Okay, we have this circle and this is the center, radius capital R. Okay, the radius vector capital R. And the boy is moving with a constant speed on a circular track, right? And the constant speed is basically u. Let's call this boy as a p. Now because of the motion of the boy, it is moving on a circular track, so its radius is basically rotating continuously, right? It is rotating like this, and it is all the u vector, the direction of u is always perpendicular to the radius vector, so it is moving on a circular track. It's like it's a uniform circular motion, right? Very good. Now the story of the second boy. Second boy is initially at a center. Let's call it Q. Now the story of the second boy is such that always remains on a radius connecting the center of the circle and the first boy. Very good. That means this radius vector is rotating, but every moment the second boy Q is on this line only. Now think how it is possible. It is only possible if the first boy rotated by 30 degrees, second one Q has to rotate by 30 degrees. That means they must have equal omega at every instant. The angular speed of P and the angular speed of Q must be equal. That is the only condition, so that they rotate through the same angle in a same time, right? Like in case of fan, if you make any dot on a fan, I mean the multiple dots you make on the wings of a fan, all the dots are moving such that they have equal angular speed. They rotate through an equal angle in an equal time. Okay, so this is the one of the key point we will use. The second one is the second boy have a constant velocity, the numerical value, okay, and that is v, right? Now this second boy has to chase the first one, so this velocity vector will be utilized in a two ways. At a general moment, let's say the q is somewhere here, so q will be moving at a certain angle such that one component will maintain its angular speed equals to the angular speed of p, and other component will make it move towards the p, or you can say it is moving along a radial direction, right? So that it can chase the p. Now your next question may be, sir, how it is possible? Both have equal velocity. So if one component is used to provide the omega, the same omega, then how it will have the second component in a radial direction? The reason is omega depends on the omega depends on linear speed as well as the radius. So this q have a less radial distance from the center, right? Let's say this radius is small r. So how will you write the value omega of the q? It will be one component of the velocity perpendicular to the radius and the small r. Whereas if you write the omega of p, it will be u divided by capital R. As you know that capital R is more than small r, right? So this component is going to be less than the u. So only a fraction of the velocity will be used to provide the omega. What about the next component? I mean, one component will be here, no? This component which will provide the omega. But we will have one more component in a radial direction, right? This is a velocity perpendicular to the radius. This is a velocity parallel to the radius. So the parallel component will be used to increase its radial distance, right? dr by dt. And when it will chase this first boy p, at that moment the radius will become capital R, right? The small r will become capital R. That is the task. So we need to calculate the time when the radius become 0 to capital R. That is our task, right? So somehow we need this velocity, v parallel, right? Now we have this one relation that v perpendicular divided by small r is equal to u divided by capital R. So here I can say v perpendicular is basically small r divided by capital R multiplied by u. Here small r is variable, u and capital R is constant, right? And if I add these two vector, I mean the v parallel and the v perpendicular, if I add these two vector in a vector form, I will get the v, right? These are mutually perpendicular, so I can write like this, the addition in this format, right? Is that okay? Now the remaining part is just the mathematical part. Let's do that. I think it will be perfectly okay if I write down like the component which is parallel to the radius as a square root of v square minus v perpendicular square, right? And this v perpendicular can be written in two parts, right? V perpendicular square can be written as u square divided by r square multiplied by small r square, right? Now the numerical value of v is equal to the numerical value of u in this particular case, so I can take them out and I can write the v or u, whatever you write. Then if I take r square also common, so it is capital R, right? And now we will have capital R square minus small r square. So this is a parallel component. If you put the value v and r, it is v is basically 4 and capital R is 28, right? So here I will put this parallel component. So it is v divided by capital R multiplied by square root of capital R square minus small r square is equal to dr by dt. Yes or no? So v divided by capital R dt is equal to dr divided by square root of capital R square minus small r square. Now integrating both sides, the small r need to change from 0 to capital R, right? And this dt will change from 0 to t, and t is our answer, right? So it is v divided by capital R, this is capital T, the integration of the left hand side, and the right hand side we have a standard formula, or you can use a substitution method. So it is sine inverse small r by capital R, right? Now I can put the limit from 0 to capital R, right? So if you put the value of v and the r, it is 4 divided by 28. 4 divided by 28, capital T we need to calculate. On the right hand side, if you put the capital R, it will be sine inverse 1. Sine inverse 1 means pi by 2, right? Then sine inverse 0 is 0. So it is 0 like this. So the T will be 11 seconds. Now the task for you to solve this problem, and you can write your answer in comment section. And that's all for this video. ఈ రోజుకి ఇంత చాలు, వాల్యూ వస్తా.